Hello Year 12 Single Mathematicians, just going to continue with Chapter 1, the second half of subsection 1.3 today, which was to do with partial fractions. So this is partial fractions part 2. The main objective today is to split expressions with 3 distinct linear factors into partial fractions. What I mean by that is 3 brackets on the denominator where the a, b and c values are all different. Now firstly you have to know what these split up into. So again, you should get into the habit of using the identity symbol, and this was split up into 3 separate fractions, very similar to the previous type. So something over x plus a, something over x plus b, and something over x plus c. And you need to remember that. So question will look something like this. You have a an expression with 3 distinct factors on the denominator. Now if the denominator is not factorized, that is one thing you will have to do yourself. Okay, so definitely check to see if the denominator is factorized. This one is. Now I can predict what this is going to look like. So I've got 6x squared plus 5x subtract 2 over x brackets x minus 1 brackets 2x plus 1, and that's going to split up into, use the identity sign again, something over x plus something over x subtract 1 plus something over 2x plus 1. And now this is the slightly strange part where you take the right hand side and you write it as a single fraction over the same denominator. So you kind of do work backwards, if you like. Now when you do that, just make sure you times the numerator by the correct amount. So this numerator would be times by both of these. This numerator would be times by both of those, and c is times by both of these. And that is all over the same common denominator. Now because they're over the same common denominator, you can effectively forget about those, and it is the same as 6x squared plus 5x subtract 2 being identical to a x minus 1 2x plus 1 plus b x 2x plus 1 plus c x x minus 1. Now you've got 3 unknowns, a, b and c. And because this is an identity symbol, I'll remind you that means that it works for every single value of x. Now normally if you've got 3 unknowns, you would expect 3 equations with those 3 unknowns, which you can definitely generate. Or an easier way to do it is to pick 3 very specific values of x, and you end up with 3 really straightforward equations to solve. So the values of x you should pick would be 1 in this case, and you'd have 6 1s squared plus 5 1s subtract 2. If you put 1 into this first term, that bracket goes to 0, and anything times 0 is 0. If you put 1 into this final term, again that bracket goes to 0, everything else that bracket goes to 0 and anything times 0 is 0. So the only term you are left with is the middle term, which would be b times 1, 2 1s plus 1. And then let's simplify this. So 6 plus 5 subtract 2 is 9. b times 1 times 3 is 3b, to give you b is equal to 3. Okay, then you pick another value of x. Another good value to pick would be 0 in this case. You always pick the values which make those brackets 0. So 2 is equal to, second two terms disappear this time, and you're left with a minus 1 times 1, which gives you a is negative 2. And then one last value of x to pick. X is equal to minus a half, 6 minus a half squareds plus 5 minus a halves, subtract 2 is equal to, first two terms disappear and you're just left with the third term, c minus a half minus 3 over 2. What would this be? So that would be a positive quarter times by 6, which is 3 over 2. Subtract 5 over 2, which is minus 1. Subtract 2 is negative 3. And then this would simplify to positive 3/4 c, to give you c is equal to minus 4. Okay, and the questions I would like you to complete are on page 11, and it is questions 4, 5, and 6. And that would be it.